that's not small scale when you're talking megawatts to me. I mean, that's just,
You know what? I guess what blows my mind is that it's all 1,600 amps is what I'm putting out there. It's just a 1,600 panel. I would have thought we would do with more with that, but of course it goes from there to the transformer and then to the substation.
Okay, so this is going straight to utility then.
Yep. The city owns it, so I don't know how they're gonna do that, but that'll be all on their end.
Okay. All right, I'm going to share my screen. I had a little bit of a well, I wouldn't say a little, but I'd say a pretty big computer problem. But you guys, I'm going to turn you back on your audio. That's good. So everybody can hear me just fine, Robert.
Yeah, I can.
RAM one.
Yeah, just James.
All right. So I'm gonna basically James, this is really kind of your show. I hope you guys kind of what I think I need to kind of review with you. I'm gonna have to mute him after all because I think I can still get background noise on you, James. If you need anything, just wave your hand or just hit the chat button and chat with me. That way I can hear you. Okay. All right. So I think John, were you thinking mainly on services? Was that kind of your biggest kind of rough spot or?
It was. We never got a chance to talk about that exam that I took. So I don't know what my weak spot. Well, I guess I know what my weak spots are. It's mostly in the voltage drop and as you mentioned there.
All right. The voltage drop is one of those things that just like it seems like it comes and goes. I don't see it very often. So I mean, I don't spend a lot of time in class with it because I just don't want to waste a bunch of time.
Well, I did get through your video. That was the voltage drop 2-hour video on YouTube last night. So that's all helping. I'll just keep going through that until I'm comfortable. So we can discuss other things. At least that's I have that in my itinerary.
All right. So it wasn't too bad then, I guess, as far as it goes.
No.
Okay. Did you like that? Did you like the layout of that thing? I mean, is that easier for you to do voltage drop with that kind of circle approach, or?
Yeah, I like that a lot better. It's way simplified to the way I was trying to do it before.
Okay. All right. It's one of those things that I think once you get the hang of it, I think it's pretty simple to the point where you can memorize it pretty easy and not ever have to worry about formulas. Remember
your crash course book too. I've got that. That's a nice reference to go to.
And did you do some Ohm's law studying and stuff on your own, or did you go through the book? Or?
Yeah, as a matter of fact, that's what I was doing last night, and then I started to do tonight when I thought I missed your meeting.
Okay. All right. So motors, how are you feeling on the motors?
I could use help with all of it, to be honest. I'll listen to anything you got to say right now because I'm a little overwhelmed.
Okay. I did started motors yesterday with somebody, and then I didn't really get to finish it. We kind of ran short on time. So let's do services. We can start on those tonight, and then if we have time, we'll do a review on motors. If not, I'm doing motors on Monday evening at 5:30. And so if you guys want to, if you want to kind of come back and do that on motors on Monday with us.
On Monday?
Yeah, Monday at 5:30. So it'd be the 8th, I believe. Yeah, Monday the 8th. The meeting ID, in case y'all want it, just so you have it ahead of time, is let's see, schedule. Nope. Meeting ID for that one on Monday is 148-045-3657. So that'd be Monday at 5:30. And it's one of those that you can log on before I do. I think you guys, y'all see you got each other early, or was it until I logged on before you could actually get in, see anything?
It let us log in, and then we just said we'd wait. We're waiting for you. So.
Could you see each other or no?
No.
Not until you logged on.
Okay. But this one is I took the option of setting it up where you guys can log on before me. So if you guys want to get on there before and chat with each other, you certainly can. But all right, so we're gonna start with services, and I tell you, let me see if I can find my show here. Might be better, easier. Just a second. I think we kind of covered in class the basic residential services. But just to kind of do a quick review, if you got your code book handy, you want to start on page 70. 220.12 is really kind of the beginning of it, and of course I've got all kinds of stickers and stuff that kind of go with it, but just kind of as a code book review. 220.12 starts on 68 is really the beginning of it for the most part. On page 68, it actually kind of carries over from the previous page. It's the very top right-hand or left-hand corner up there, where it kind of gives you within the area of what we consider, what we use as calculated square footage. And let me see here real quick. Trouble with my mouse not working. Let's see here. All right, so we don't calculate any or don't include any open spaces, or excuse me, open porches, garages, or any space that's not adaptable for future use. And that's pretty self-explanatory. I mean, if there's an area that's a basement, for example, that doesn't have power, if it has power, it maybe doesn't have a hot, tall enough ceiling for it to be considered to be a habitable space as far as the international building codes go or anything else of that nature. That would give you an area to exclude as far as that goes. And I have not seen them give any basements or include anything except I think I've seen an enclosed porch listed a couple of times, and occasionally they'll mention a garage. So as far as the garages go, we always exclude those. An enclosed porch is not listed as something we exclude, so it would be included. And of course, the theory, I guess there would be that the likely that somebody would go back and make that a living room or a game room or something in the future. But an open porch would maybe be more like an add-on later on as far as that goes. This is a question here that I'm going to come back and do here in a minute. Let me take a look at these slides real quick and see where we're at. The second thing, or the two most important tables that you'll deal with as far as the starting point goes, is going to be table 220.12, which is on page 68 on the right-hand side, or right-hand column there. And I think we mentioned in class that the dwelling units is one peculiar slot there, as well as, I believe, hotels and motels that have provisions for permanent cooking. If you'll see right beside the word tenants there, and right beside dwelling units, both of them have that little A letter next to them. And that little letter A just denotes the fact that, you know, even though this is a lighting table, we're going to use it for both lighting and general purpose receptacle power for those two types of occupancies. So all your plugs in the living rooms, the bedrooms, the hallways, all that stuff is already included in that number that you're looking at on the far right-hand column there, which is 3 volt amps per square foot. So it's really simple. We're just looking at 3 VA per calculated square foot. We'd exclude any open porches or anything that would have a, let's see here. Can you guys see my screen okay?
Yeah.
Okay. All right. So we're looking at exactly a good example of what we're talking about here, where we've got, get this out of the way. I don't need to talk about Pepper here right now. All right. Is it better?
Yeah.
Okay. So if we had a residential dwelling with a 3,000 square feet livable space, a 600 square foot garage, 1,000 feet of unfinished but future habitable space, calculate the minimum size aluminum feet are required for this occupancy. I'm gonna add some stuff in here because this is going to give us below the minimum standard. We won't get anywhere close to 100 amps on something like this. So let's do a 12 kW range, and we'll just do it as a single unit range. A 4,500 watt dryer, a 5,000 watt water heater, a dishwasher run by a 1 horsepower 120 volt motor, single phase motor. And a disposal that's a 3/4 horsepower at 120. A heater, no, see an air conditioner. And it seems like lately they've been giving AC units as like an actual amperage value, and then the voltage rating as well. So they give you like an AC heat pump unit that's like 30 amps at 230 volts. Okay, so 30 amps at 230 volts. There at 230 volts. A blower motor that is going to be a 2 horsepower, 240 volt motor, and supplemental heat strips. Supplemental. That's not right, is it? Anyway, yes, you're right. There we go. All right. Heat strips are 11 kW. I'm sorry, let's do 8,500. At 8,500, that's about right. Okay, so that gives us a pretty good, first, probably a closer example of what might actually happen in the world as far as like what you might know about doing as far as like size and residential service. So we had all those figures. The first thing we do in the residential standard method, and it's always going to be standard method unless they tell you specifically otherwise. So that's kind of your default steps. Is going to be the first step is going to be to take all of your square footage under that first 220.12 and take them at 3 volts volt amps per square foot. So we're going to include the 3,000 square foot living space. We will exclude the 600 square foot garage, but we would include the additional 1,000 foot for the unfinished with future applicable space. So we'd end up with a total of 4,000 total calculated square foot that we multiply times 3 volt amps. Okay, that'd give us 12,000 on that one. And when you're doing this stuff on your test, if you're writing them down on your scratch paper, I would convert everything to kW as you're going on, because that way when you're putting them into your calculator, it's a little faster. Plus your answer is going to give you, what your screen's most likely looking at. So just convert everything. So instead of putting in, 3,000 plus 1,000, just use 3 and 4. Just remember that when you divide anything that's less than 1,000, for example, if we're going to take our total value and divide by 240 volts, we'd divide that by 0.240 just so that you keep your decimals in the right spot so it'll all work out. Does that make sense?
Yeah.
Okay. So 12,000 kW is what we'll have for the lights there and the plugs. That's all the 15 amp plugs everywhere in the house. Now, there's a few code requirements that we have to include as far as the 20 amp, 125 volt required circuits, and those are going to be the two kitchen circuits. And all of this comes out of 220.52A and B. If you take a quick moment to just kind of flip over there and highlight that real fast. It's a 1,500 VA value for each one that's required by 210.11C. 220.53 is the section that has the requirements there. And I am missing that page, of course. 52A and B. Yeah, different book here. All right, so the 1,500 VA under the A section tells you got to have 1,500 for each one of those required. And just jot yourself a note. You have to have 2 of those, so there's two required at 3,000 volt amps for that A section. And then the B section for the laundry is going to be an additional 1,500 VA minimum. So total then, if you take those 3 into account, that's a total of 4,500 volt amps, and those are mandatory code minimums that you can't exclude. Even if they tell you they want to exclude them, you can't. You're going to have those included in the standard method. So you're looking at a total of 4,500 VA is what that works out to be. And we're going to add that right here before we take our D-rate. We are permitted to D-rate that along with the lighting load. So we're going to add a total of plus 4,500 VA here for the 3 required circuits. So we're looking at a total of 16.5, is that right? 16.5 VA, right? All right. Which of you guys thinks that if we had that potential on the house, how close do you think we'd ever come to actually hitting that in any given day, 365 days out of the year, just pick a day? How close do you think we'd ever come to hitting that? In just a random house. I mean, even a 5-family or 6-family dwelling with 4,000 square feet, you know, the chances are 16.5 is not that much, I don't think. Let's see, 16.5, just out of curiosity, divided by 0.240. You're looking at a total of 70 amps, right? I mean, if you don't have, and we're just talking about the lights and plugs. We're not talking about, you know, air conditioning or heating or any kind of a, you know, range or dryer. We're just talking about the lights and plugs. 70 amps worth of power? Not even close. I mean, I probably have every light in the house that I can have. So my point is that we're going to derate these. Somebody living next to the train tracks?
Yeah, that'd be me.
All right. The next table on the very next page, if you're on 220, well, actually, if you're on 220.53 or 52, it's probably right there to your left. But it's 220.42 is the table that gives us our first D rate. So it's 220.42, and it's on page. It should be on the back pages. It should be on 70, is it not? You see it on the top left-hand side of page 70?
Lighting loads?
The demand factors there that they allow us to take a D rating on. So we're derating this first step 1 and step 2, we'll call it, the lights and plugs, plus the required outlets. We're going to derate those as a value of 3,000 volt amps is 100%. And then anything above that amount, we're going to take a whopping 35% is what we'll keep. Now, if you think about that, that's really a 65% derating, but you know we're keeping the math this way because that's what's going to give us the value that we're keeping anyway, which is ultimately what we're looking at. So I'm going to say that the first 3,000 volt amps is something you don't want to touch. It's kind of your cushion to make sure that you got at least that much covered. They don't allow us to derate it, or they do allow us to derate it, but we're derating it technically at 100%, so it doesn't lessen it by any means. So I'm going to take 16.5, and I'm going to subtract. That's not AV; it's supposed to be VA. Sorry about that. VA. I'm going to subtract 3,000 from that number because I can't touch that. So you can't touch this. No MC Hammer fans? Okay. All right. This is serious business here. All right. That leaves us a balance of 13.5, and that's the amount that we can take a 35% D rate on. So I'm going to take that balance of 13.5 and multiply it times 0.35. That's going to give me a balance there of 4.725. 4.725 VA. And then, for God's sakes, whatever you do, don't forget that 3,000 that you took out temporarily has got to now be put back in because we don't want to lose track of that. So that 3,000, we just removed it so that we could get to the portion that we could derate, but we don't want to forget it. And as a habit for me on tests, when I take these guys, I'll on my scratch paper, I'll make just kind of a tally sheet on the right-hand side of all of the things that I'm keeping as far as values go. And so it's just kind of your running, tally sheet for your feeders or your service calculations on the outside. So we would keep the 3,000 just right to the left or to the right of the page. And then we'd also keep this 4.725, which ultimately results in 77.25 as far as your lights and plugs go. So 77.25. Okay, VA. All right, that's step 1 and step 2. Next step is going to be this range that's listed. And you can do the rest of them in any order you want, but let's just look at the range first. John, tell me what we'd calculate for that range and how you go about it.
Actually, I have a question. That must have missed something. That 4.725. Where do we go from? We subtract that 3,000 to 16, or the 3, excuse me, from 16.5 to get our 13.5.
Yeah.
That's just for that 100%. That's that D rate, I guess, that 3,000 first 3,000, right?
Yeah, I took from the 16.5, which is the total, connected load. I'm taking.
Oh, wait a minute. Is that your 35%?
It's 35%. That's right, of the 13.5.
I missed that part.
Yeah, we took this right here is the connected load, which is the 16.5.
All right. I got it.
Okay, and the D rate steps are these two right here, which is this first block at 100% and the balance at 35%. I just didn't have it typed in there.
Okay.
0.35. equals the 47 or 25 volt amps. And then we go back and add the plus 3,000 back in here right there, this step right there.
I'm caught back up. Now, what was your question?
Okay, the next thing we're looking at is this range up here that's listed, this 12 kW range. Tell me what you calculate and how you go about it as far as the demand load goes for that in a question like this under the standard method for a single 12 kW range.
There's like a $5,000 or excuse me, 5,000 something in there, a column, table, something.
Yeah, if you're thinking about that, you're probably thinking about a dryer. You're probably.
Oh, you're right.
So look on page 72, which is your 220.55. That's the table that we're going to use here for that one.
Okay. Yeah, there we go.
Okay. So you're looking at really a value of what for that 12 kW range?
You're looking at a bunch of stuff written in here. Just a single one.
Yep.
There's 8.
That's right. So you're just looking at the fact that, first of all, it's a service calculation, and second of all, it's there's just one of them, so you're on row 1, and of course the size of the range is 12 kW, so it doesn't go past 12, column C, but it's certainly past column B, so it's got one range there at column C on row 1 would be 8,000 watts. So there's really no math involved with that one. It's just you're substituting that 8,000 for the 12 kW, so the 12 kW becomes simply an 8,000 watt value for the demand load. Okay. So what I've got so far right now is this this value of 7725 plus the 8,000, right? So I'm looking at this number here. I'm just going to highlight the stuff we're keeping just so that we kind of keep track of it there. Well, highlight it, we'll just make it red. And then this 8,000 being also demand load there. All right, so connect load 12 kW, demand load 8,000. And then James, what do we have on this this dryer here?
Don't we go back to the 22054?
That's right. So 220.54, and you have a minimum value there under the article, and you have a table there as well. The table.
Yeah, it says 1 through 4 is 100%.
Huh? Wow, that's beautiful. Father's Day present. Father's Day present. They like that. It's one of the G-Shock watches. I got a good wife. What can I say?
Yeah.
All right. So we're on page 70. We're looking at 220.54. The tables on the left-hand side. The article actually starts at the bottom of the preceding page on the very bottom right-hand corner. 70. No matter what, in the standard method, now this does not apply to the optional method, guys. This is one thing that is kind of confusing to a lot of people. But the standard method, which is what we're calculating this under, is going to include a minimum value of 5,000 watts for any dryer listed less than that. So we're looking at really bumping that 4,500 watt up to 5,000. And that's a subtle thing, guys. It's really easy to miss something like that or miss a step like that. But keep those dryers in mind when you're dealing with services, especially in the standard method like this. All right, so we're going to end up having to take an increase then of 5,000 watts. We're going to take the 4.5. I'm going to do that in red. Oh well. There we go. We'll take the 4.5 and we'll increase that to 5,000 for the dryer, and that's going to give us another number to add to that. So we're looking at 725 plus the 8 plus the 5. All right, so the table tells you on the right-hand side, left-hand side of page 71, 1 through 4 dryers in residential dwellings, 100% value. So now if you had a nameplate that was more than this 5,000 watts, you'd take that instead. But since this is below it, we'll have to bump that up. All right. So it's 5,000 watts for the nameplate, whichever is larger. All right. Next is going to be the water heater. The other ones are going to be motors and air conditioning. So on the water heater, what do we do with that? Look in section 220.53. Let's talk about water heaters just for a second. Dot 53 is going to tell you that is a fast in place appliance, which is going to be water heaters, vent hoods, microwave ovens that are part of like a micro vent hood combo, trash compactors, anything that's not listed specifically as a motor value, or anything that excludes ranges, dryers, and space heating, or air conditioning and fixed in place space heating and stuff of that nature. So water heaters falls in that category, but you have to have a magic number of at least 4 of those fastened in place to be able to take any kind of D-rate. So we're really looking at just the 4,500 nameplate rating. Excuse me, I give you 5,000 on the water heater, so we'd have 5,000 watts for the water heater straight across. Now, if you take a second just to turn back to 422, 422.13, I believe it is. 422 is a section that's so far away from where we're at right now that you have a tendency to kind of forget about it, but it's actually a pretty important section that kind of ties into a lot of what we're doing here. But 422 let's see here.
13.
Is it 13? It sure is. So a fastened in place or a fixed electric water heater that's got a capacity of 120 gallons or less is considered a continuous load for the purpose of sizing branch circuit calculations. So it is considered to be a continuous duty load, but not when you're doing a service calculation. So for a branch, we would end up taking that 5,000 watts and increasing it by 125%. But for a service calculation, we're taking it straight across the board. Okay. You'll see the same exact kind of mental approach to the space heating as well here in just a second. As a branch circuit, is considered to be continuous duty, but as a service calculation, which is what we're doing here, it's just 100% of the nameplate rating. So both the water heater and the heating here in a minute, we'll just take it 100%. But right now, we're taking the 5,000 watt water heater, and we're just going to take it as 100% of 5.0 as well. And that is, of course, added to the tally that we've got rolling over there for the other ones. All right. The next thing we're looking at is all those motors, right? What do we do with those motors, and how do you get started on them?
Go to the motor tables.
Yep. Page 350 on the single phase motors.
And 3/4 horsepower.
Yeah, we're trying to get a starting point to calculate against, as far as like an ampacity for them. So if you're on page 350 on the FLC tables there for motors, single phase, that's going to be the one that's on the first upper left-hand side of the page. The larger table that's on your right-hand side of page 350, make sure you got an X to that. Don't try to accidentally use it in the middle of the test. You wouldn't use it in the trade either. I don't know why they even have that table on there, but it's not something you'll ever want to use. I don't know that I've ever seen a two-phase system in my entire trade. I know they're out there somewhere, but not anywhere that I've ever seen, and I don't think I've ever had any students ever tell me they saw one either. So, but on a single-phase table, you're looking at the first motor that we've got here. We're looking at this this dishwasher. So we've got a dishwasher that's a single horsepower 120 volt, a single phase. So you're looking at what number?
16.
430 to for a single phase 120 volt. Now we're using the 115 volt column there, but it's just a nominal voltage range. So we're looking at a value of 16 amps at 115 volts for single phase 120 volt motor. Now the problem is, guys, is that if you do a lot of motors, like in this problem where you're looking at, if your answer blocks are real close together, then I'd be cautious of the motors, because you're looking at a horsepower rating, and I think you guys probably know that a single horsepower is equal to 746 watts, right? Have you ever heard of that one before?
Is what?
Yeah.
Ideally, in a perfect world with no losses and no efficiency issues, a single horsepower would have a rating of 746 watts.
Yeah, I've heard that.
None of these motors on these tables come anywhere close to that because of the fact of efficiency and losses and power factors and stuff. But if you're looking at a horsepower rating, it's the same thing, or it has equivalent rating in watts. And horsepower ratings on a motor don't change, do they? I mean, if I take a 2 horsepower motor and I put it on the service, it's got 230 volts because we're at the very end of the transmission line. I can still use that same exact motor if I take it from there and go somewhere else. Maybe I'm right next to the transmission line. I got 250 volts. If I connect it, it's still going to give me the same 2 horsepower, right?
Yeah.
I mean, the horsepower rating is what that motor is designed to produce. What the product is of those two, that horsepower is the 2 values below it in an ohms law calculation. So if you're looking at horsepower as far as the product of what produces those works, it's the amps and the volts. Well, to create this table, they knew what the horsepower rating and the watt rating of that motor was to begin with, right? They divided that number by 115 volts to give you this 16 amps that you're looking at on the table. So to convert that back to volt amps, I'm going to take this 16 amps and multiply it times 115 volts, not 120, because that's what they created this table with. Does that make sense? Okay.
Yeah.
Do you have any questions about that, John?
Not so far.
Okay. All right. So I'm going to take the 16 times 115, and that's going to give me 1840 volts for that volt amps for that dishwasher. I'm just going to put these in parentheses here. So 115 volts times 16 amps gives you a value of 1840. All right, and the next one is going to be the 3/4 horsepower disposal, and again, same thing at 13.8 amps times 115. 13.8 times 115 is going to give me 1587 VA for that one. Now, if the answer blocks are pretty far apart, then it's not necessary because you're going to get close enough to your answer that it won't make a huge difference. But if they're pretty close, you want to be specific with it. But the last one's going to be that 2 horsepower, 230 volts, I think it was, for the air conditioner. Air conditioner is going to be kind of a special case, but that blower motor is just a motor load. So 2 horsepower, 240 volt would give us value of 12 amps at 230 volts. So 12 times 230 leaves us 2760 for that one. So those 3 motor loads are in that order. And the largest motor in this service, if you look real quick on 220.18a, which is going to be back on page 69 on the right-hand column, 220.18a. We're looking at basically the bottom part of that. Circuit supplying loads consisting of motors larger than 1/8 horsepower in combination with other loads. The total calculated load should be based on 125% of the biggest motor plus the sum of the FLC values of the other loads. So we're going to take the biggest motor, in other words, then, and increase it by value or a factor of 125%, and then just add 100% of the other VAs that we've calculated up there. So the biggest one being the 2760, multiply that times 1.25, and gives you value of 3450 for that one. So I'm going to go back here and adjust this one by 125%. $34.50, and that's what I'm going to use in lieu of this 2760. So this is a connected load. This is a demand load, and it's just so happens that our demand factor happens to be more than 100%. So it can do that. It can go up or down depending on your factors. So this will actually be the value that we're using for that one. And to pick those other ones up, we had let's see, this 1840 at 100% and the 1587 were the other 2 we're going to pick up there. We also had the 5000 for the water heater at 100%, and we had the the dryer at 5,000 watts as well. All right, that is everything except the air conditioning and heating. If you look in your code book on 220.51, which is the very bottom left-hand corner of page 70, 220.51 tells you that fixed electric space heating is going to be calculated at 100%, so we're just going to take 100% of the fixed electric space heating. But if you also look at 220.60, which is on the right-hand side of page 71, non-coinciding loads that don't operate at the same time, you can take the larger of the 2 loads if you have a situation like that. In this case, a central heating and air conditioning unit like this would either run the air conditioning during the summertime or run the heating during the wintertime, but they wouldn't run simultaneously, so they're non-coinciding loads. We're going to omit the smaller of the 2. So that AC unit at 30 amps at 230 volts, 30 amps times 230 volts would give us a value of 6,900 VA. The heat strips at 8,500 are going to trump that. So we're going to just basically forget all about the air conditioning, and we're going to calculate the 8,500 at 100% for the heat. So omit AC, and 100% of the heat would be plus 8,000, 8,500, 8.5 kW. Okay, or kVA. All right, so any questions on any of that, guys? All right, good. That is the total value, and that's exactly the process you go through. It's kind of a tedious process. The standard method is very exact, and it has, you know, a ton of steps. You derate every one of the steps individually in their own sections. There's things to remember about each one of them, so be careful of the, you know, the minimums and stuff that you've got. All right, so we're looking at a running total here of the 7725 for the lights. We've got the 8 for the range. We've got the 5 for the dryer, the 5 for the water heater, the 1840, the 1587, and 3450 for the motors. So plus 1.84 plus 1.587 plus 3.45. And then the larger of the two, air conditioning and heating, is going to be that 8,500, so plus 8.5. I come up with a total value of 41,102. Does that sound right to everybody? Make it anything different? Go back just to make sure I didn't forget anything. If I subtract from 41,102, if I subtract my 8.5 for the heat, subtract the 8 for the range, subtract the 3 motors at 1.8, 1.5. And then I've got the 7.725. And then I've got the missing something here. 3450. No, that's right. All right, so I think we've got everything in there. So 41,102 VA in the total calculated value there, and that's basically a service calculation. And if they're just asking you for a service calculation, that's all you have to do. You're good there.
You don't have to divide by 240.
Now, here's the deal. We used to have a table that was specifically for residential feeders that was 310.16B7. Now, if you look on page 160 of your code book, they took that table away from you, and they added this mysterious verbiage that tells you basically that no service feeder or service feeder is permitted to be a value of some to you exactly. So I'm not just paraphrasing it. It's kind of hard to understand, but I'm looking on page 160. I'm on the right-hand column, kind of at the top there, where it says section 1 kind of leads over. It actually starts at the bottom of the left-hand column. For a service rated 100 to 400 amps, service conductor supplying the entire load associated with a one-family dwelling, or the entire load associated with a two-family or multi-family dwelling, is permitted to have an capacity not less than 83% of the service rating. Okay, well, not less than 83% of the service rating means that I'm looking at a factor of 83% against this 41,102 now, as a more accurate way of sizing my feeders instead of the old table that we had, where we had, you know, fixed blocks of steps that we had to, you know, stop at. So I'm going to take this 41,102 and I'm going to multiply it times 0.83 from that section by sizing the wire for residential feeders. So it's just a new demand factor. That's just another additional step that you're going to have to remember to do on residential feeders, but it only applies to residential. So times that value times 0.83 in your calculator.
Where'd that come from?
It comes from 310.16B7 on page 160. Take a quick minute to read that and highlight it real quick if you don't mind. And coming from the service side, this is exactly how you want to calculate that. You would multiply it against your volt amps, or if you want to go ahead and divide it out by 240, so you've got your amperage values, and then times it times 0.83. Either way, you're going to get the same math. It doesn't matter. You you're going to divide them, by 240 one way or the other. So I prefer to do it against the 4100 volt amp so I can kind of keep it straight. But I'm looking at taking this 41102 and multiplying it times 0.83. What that does is it reduces the service value to a value that's now the equal standard of what a commercial building would be. In other words, a wire in a residential dwelling is worth more there than it would be in a commercial setting. So to give you the same analogy, if I'm looking at a service rating, I'm going to lessen that because the commercial, the opposite direction. If I took a commercial wire, it would be worth. Excuse me, I said that backwards. That a commercial wire would be worth more in residential service. A service residential wire would be worth less in a commercial building. So we're lessening this residential wire so we can get the equal equivalent of what you're looking at on page 161. So I'm going to take that times 83, and that's going to give me 34,115 as an adjustable volt amps for that residential feeder. Is there any question on what I just did or what I just said? Okay, so I'm going to then turn around and divide that number by 0.240, or if you're doing it as as volt amps to the kVA, it'd be divided by 240 volts. It gives you 142.14 amps. Which, no matter what your decimal point is, you're always rounding up to the next larger size wire anyway. So really, effectively, that's 143 amps is what I'm going to put down here just for reference there. So I'm looking at a value of 143 amps. Now I can take that number and go straight to page 161. I'm at a value that's above 100 amps, so I'm permitted to use the 75-degree column if they don't give me a wire size specifically. But remember, I'm looking for an aluminum wire, so I'm going to be on the second three columns on the right-hand side of the page there for aluminum. On the 75-degree column, the 135, which is what a 2-aught is, we just missed it. So a 3-aught at 155 amps would be the correct aluminum conductor there. I'll make sure I got that right. Yeah, 155 amps. I'm looking at 3-aught then as a residential feeder there. That's a lot to assimilate all at one time, but that's the worst that they could give you on standard method calculation. That's every bit of it all in one example. Okay. If you guys want an email copy of this stuff, just let me know at the end of the night, and I'll just send you an email so you'll have the same one that I've got in front of me. Just kind of as a reference there on your notes. And then I'm recording this session too, so I should be able to give you a copy of the recording if you'd like to have one as well. All right. The next example is going to be this one's kind of tough. I'm going to use this one, but I'm going to change it just a little bit. You know what? Let's go back here. I take it back. Let me take this one, copy it. If I turn around and ask you to do this same exact one, I'm going to take all this down here. Does everybody have all those numbers there? Okay.
Yeah.
I'm going to erase that. If I were to turn around and ask you to use the optional method to calculate this same exact question, okay? I'll tell you, nobody in their right mind in the real world wants to use the standard method of calculation to size a service residential dwelling because, first of all, you normally don't know all of the values anyway. I mean, it's everyone I've ever done, which is granted not that many of them, but all the custom homes for sure. I didn't know until we were doing the last few parts of the job what range was ultimately going to be picked by the guy that was building it. Because it was one of the last things he did was he'd go down to IKEA and buy some names I can't even pronounce, and then come back with them and say, oh, by the way, can I put a cooktop and a wall mount in? Is it too late for that kind of deal? But you kind of take for granted some of this stuff up front anyway. So the standard method, knowing that you have to know what your values are in every single step, is kind of hard to attain sometimes. So you're permitted under 220.82, which starts on page 73, to use what's called the optional method, and it's a method that I promise is a whole lot easier than the standard method. But what I like about it is that the format of the instructions are in a nice manner. I don't know if you can kind of see mine or not, but I've got them kind of written with some, I mean, basically got the whole thing highlighted. It's kind of hard to see there, but not really good light there. But I'm on 220.82 on page 73, which is the left-hand column. And I want you to take a different color highlighter than what you've got anywhere on this page, and I want you to highlight that part 4 that says optional feeder and service calculations, because you're basically making a line in the sand that anything below that part 4, none of what we just talked about applies. None of it. Not the minimum 5,000 for the dryer, not the table that you see on page 72, which is your range table, none of it. Okay? The only thing that applies, if you look at the heading of A, which says 220.82 dwelling unit, right down the last sentence there of the paragraph A says, feeder service entrance conductors whose calculated load is determined by this optional calculated are permitted to have the neutral load determined by 220.61. Other than that, this is a whole different animal. That's the only part of part 3 that's included in part 4. If you look at B, then B is really the optional method, and that's the mechanics of it, and it's real simple. They give you a list of, in step 1, of all of the areas, just like, under the standard method, under dot 12, you had that where we started at. They can tell you what to include and what not to include, and how much to include for each one of those square feet in the same little paragraph there. So B1 tells you to take the square foot minus any garage or open porches or unused, unfinished space not adaptable for future use. And then under the very beginning of it tells you that 3 volt amps will be included for each one of those. So the beginning starts are going to be almost identical. I'm still taking the same 4,000 square feet. Still taking the same 4,000 square feet. And I'm still going to take the 3VA and still going to end up with the same 12,000 that I had on the standard method. And then I'm going to turn around, and under part 2, I'm going to add the same 1,500 for each one of the 3 required 20 amp circuits, which are the 2 kitchen and the laundry. So I'm doing the same step here again as well. I'm doing the plus 4,500. That doesn't change either. That's going to give me a value then of the same 16.5 that I had in the standard method. The difference is that I don't derate it here. I'm just going to keep on trucking. So I've got basically a value here and here that I'm not going to do anything with right now. I'm going to go under B3, and B3 has a list of a whole bunch of stuff, A, B, C, and D. They're all basically all the other things that we did in the the standard method. A is all appliances fastened in place, which, if you remember, we could take a 75% derating on the standard method. We had 4 more here. It's the nameplate of everything in the house, basically. So if we're looking at the same stuff, that water heater was the fastened in place appliance that we had that doesn't include like your range, dryers, motor loads, things of that nature. So the water heater at 5,000 watts was the only one we had there. I'm just going to take the whole amount at 5 kW. And that's pretty much it for the fast in place appliances that aren't motor loads and that aren't air conditioning or ranges or dryers. So the next thing is going to be B, which is ranges, wall mounted ovens, so on and so forth. I'm going to add plus 12K, and I'm not derating it. The table that's on the right hand or your left hand side does not apply under the optional method of calculations. I'm taking the nameplate rating of it at full face value. No derates. So 12 kW for the range. Then on the dryer, which is the next thing up there at the list, which is also what section C there is, I'm going to take the 4,500 nameplate rating, not the minimum 5,000, because it does not apply in the standard and the optional method. It only applies to the standard. 4.5 kW for the dryer. And then under part 4, I'm looking at water heaters, which I've calculated as fast and appliance on the version, so it's already included in there. So we're looking at, let's see, I didn't have the 16.5 up there. So the first step was the 16.5 VA for the lights and plugs, plus the 12 kW for the range, plus 4.5 for the water heater, dryer. The water heater was 5, and the dryer was 4.5. All right, and then under the motor loads, Motor loads are calculated under section 4, which is the very bottom of the column there on the page, left-hand side. I'm taking those at 100%. I'm not worried about any 125% increase like we did on the standard method. It's just straight across the board, which was 2760, was it? It was, 2760, 1840, and 1587. 1840, they're not necessarily in that order. And then 2760, that's what those three motors were in the standard method. And I'm going to take those at 100%. I'm not taking any increase for the biggest motor. So that's the last of the major differences there between the standard method and the optional method. All right, I'm going to add all of that together, but I'm not worried about the air conditioner heating. That's the other thing that's kind of different here. If you look to the right-hand column up at the very top of the next column of the page there, you'll see section C, but section C is a separate step. So write yourself a note at the bottom left-hand column of page 73 there that you want to stop after you're done with the motor loads under section 4 there, B4, and then draw an arrow up to the top of the paragraph there where it gives you your D rating values listed under B right there at the very top where we were at. Kind of the top.
73, what?
On page 73 on
Oh,
the
I got you.
yeah, on the left-hand column at the bottom, when you're done with step 4, B4, you want to make yourself a note to stop there. Don't include the air conditioner heating yet. Go back to the top of B there where it tells you that we're going to take these values all together and take one big D rate against the whole mess. But we're keeping the first 10,000 now instead of 3,000 at 100%. So I'm going to add the 16.5 for the lights and plugs. I'm adding the 45 and the 12. Plus the 5, plus the, did I count that 4.5 twice? I did, didn't I? I already had the dryer listed down there, so I'm going to include it twice. So I got the range. Let me make sure I don't want to, so 16.5 plus the 12 for the range, plus the 4.5 for the water heater. Excuse me, the dryer, which I've got a little further down there. I don't need to go up there either. So the water heater 4.5. Okay, so 16.5 plus the 12 for the range, plus the 4.5 for the dryer, plus the water heater, which was 5, plus the 3 motor loads gives us 1.587 plus 1840. Stop me if somebody's already got this answer. All right, I've got 44,187. Anybody got anything different?
I got the same thing.
Okay, that's a good sign then. 44.187, or if you're doing it in kV or volt amps, it'd just be 44,187.
What was the 2760?
The 2760 was that blower motor, which I'm including the blower motor as a motor load under section 4, not as a part of the heating, because the blower motor is going to be a motor load and it's going to operate all the time anyway, so it's not really part of the air conditioning when it comes to section C.
Oh, okay.
If they ever separate a blower motor like that on you on the air conditioning, you want to include it as just a regular motor load and then just kind of forget about what it is that it does. It's just a motor.
Okay.
But we don't increase it times 125%. We're just taking it at 100% of its rating. So I'm going to end up with 44,187 then, and I'm going to take the first 10,000 of that out of the way. And remember, that's something that I'm keeping. I'm just taking it at 100%. And the balance then, which is 34,187, is what I'm going to take a derating factor of 40% against. So 34,187 is going to be multiplied times 40% times 140. Which is going to give me $1,367 times gives me 13,674.80. 13.6748, which I'm going to round that up to 7.5, so 675 V8, and then I'm going to add that 10,000 back to that number because I remember you don't want to forget that. So plus the 10,000 back. Gives us a total of 23,675. And then we're now cleared to take off for the section C. 13,675 is going to give me a total of 23,675. Get my math right. If anybody knows any mistakes as I'm typing along, just let me know. But I think that's right. 13,675 plus the 10,000, 23,675. All right. Section C is a list of 6 items. We're going to take the larger of any one of those 6. And in this case, I don't really tell you much about what that air conditioner is or what the heating value is. That heating value is going to be taken at section 4, basically, is what it's going to look at. Section 2 is going to be a nameplate heating of the heat pump, where you've got without any supplemental heat, and then section 3 has supplemental heating listed, and they will sometimes give you something that comes out of section 3. So I would probably highlight that one just to be kind of aware of it. But in the way I've got this particular question worded, I don't give you enough detail for that for you to know kind of what's going on with that. So I'm going to take it at 65% of an electric space heating if less than 4 separately controlled units. And that's what we're really kind of looking at there. So I'm going to take 65% of the 8,500 or 100% of the air conditioning under section 1, whichever number is bigger. So I have to look at that 8,500, which is what the heat is, at 65%. It's 55.25. So by the time I take a derate, that heat load's value is less than what the air conditioner is. So I'm going to take the air conditioner load at 30 amps times 230 volts. I'm looking at 6,900 VA for the air conditioning versus the derated heat value. All right, so I'm going to take the air conditioning at 100% of that AC, which is 6,900. And that's going to give me a value then of total of plus the $23.675. That's going to give us 30.58. So it ends up being 30.58. And what did we get on the standard method? We ended up with 34. No, we ended up with 41,102, which is pretty. It's actually
34,115.
Well, remember this 30.575 is going to be actually derated in the same manner. So I'm looking at 570.58 there. Excuse me, 0.58 is what I've got kVA. I'm going to turn around and take that 30.58 kVA. I'm going to multiply it times the same 0.83. That doesn't really change between the different methods. And that's going to derate that value to 25.37 instead of the 34 that we had on the standard method. 25.37. And I divide that by 240 volts. Gives me 105.74 amps. So once I divide that by, in this case, since I'm using a kVA value, I divide that by 0.240. If you're doing it in 1,000 volts, then you just, or by volt amps, just divide it by 240. Gives me 105.74 amps. So the aluminum feeder for this one is going to be, again, the same procedure applies. I'm going to be looking at the 75-degree cone. I end up with a 1-aught instead of a 3-aught aluminum feeder for that service, even an option. Any questions? Nope. You got all that? Both of those? Pretty solid?
You use the AC instead of the heat in the optional method because the AC was
100%. The AC falls under C1, which is 100% of the air conditioning load. In this case, the heating load being at 8,500 would actually fall under section 4.
Oh, it's 65%.
which is, yeah. So I'm taking a 65% derating against that 8,500 watts, which gives me a smaller number than what the air conditioner would be at 100%. Now, if they had told me that air conditioner was a heat pump, and they told me that the heat addition, the supplemental strips that were in addition to the standard heating, but actually the heat pump values, I would, and that they were interlocked from operating at the same time, then I would be looking at taking just 100% of the nameplate, is it? 65% of the supplementary heat. If it's prevented from operating, you don't have to take the 65%. So it'd be a different story if there's a little bit more detail listed there. And they do sometimes give you that exact detail that falls under part 3. So you just kind of have to look at the heat loads carefully. All right, any questions? All right, you guys want to try one on your own, or are you good?
So far, so good.
Huh?
So far, so good.
James, you holding out okay up there?
Yeah, we're doing good.
Okay. All right. Again, I'll send you a copy of this stuff if you guys want. So if you do, just send me an email real quick. My email address, just so you have it, is just strail@yahoo.com. If you want to just cut and paste that if you can, or if you can't, just jot it down real fast and just send me an email real quick, and then that'll take me. Then I'll just turn around and just send that to you this evening. We're done. All right.
You want us to request? Is that what that is? Is that email?
Yeah. Just send me a request. Just say, hey, can you send me those slides that we did last night or tonight or whatever. That way I'll have that. I'll just shoot you a reply, and that way we don't have to worry about it. Okay. Let's look at the commercial section. You guys want to do a practice one on your own on the optional or the standard method? Most likely you'll have the biggest trouble on this test is probably going to be an optional method, most likely. That seems like I get out of most guys. And
One question to you. When do you decide to use the optional method?
only if they tell you to. You can't do it on your own. So it's always the standard method unless otherwise, specifically given to you as the optional method. So they flat out have to give that to you as part of the test. I have a test question that came from somebody's master's exam. Give me just a second to locate it. I've gotten the same question from a couple different guys, and I end up getting bits and pieces that are a little bit different. But it's an optional method, and I can find it real quick. I'll just type it up for you, and you can just try it real quick. Here it is. No, that's not it. But I'll tell you what, I'll give it to you the best I can remember. It's not one that's going to be an exact one, so this is just really for practice. But I'll look it up this evening. When I find it, I'll send it to you guys as one that you guys can practice with. Again, I don't know for a fact that I've got all the details exactly right even on that one, so I don't want you to memorize just the answer that you come up with and try to be good with that. But at least work your way through it, and then if you have any questions on it, just shoot me an email, and I'll tell you if you got it right or if I see you missing anything. All right, if you had an 1,000 square foot residential dwelling, it's 1,000 square feet residential dwelling. They give you a range. Let me get a new slide here. So, given a residential dwelling. All right, so 1,000 square feet, a range of 8,500, a 4.5 kW dryer, water heater 5.5, 30 amp AC heat pump rated 230 volts, supplemental heat strips, and you're going to use the optional method calculation. So sorry about that. I forgot to put that in there. Using the optional method of calculation. There you go. I didn't give you the supplemental heat strips. I'm sorry. The supplemental heat strips at 8,500 watts. You can just leave that the same as the other example was. Sorry about that. No, that's not right. Right, there's your choices to pick from as far as which, an answer block. Actually, and believe it or not, I think they're asking you to size the breaker size for this thing, if I'm not mistaken. Just FYI. So I think there's a couple of questions that are kind of new as far as that goes. But in this case, they're looking for, the way I've got it written, I'm just asking for the amperage that you base the wire size on and feeder size actually on. Anybody got a stab at it yet?
Um, mm, well,
Huh?
I messed up somewhere.
Again, be careful that you're always on the. You always want to make sure you're reading the question, to the exact degree when it comes to deciding on your final answer. Make sure you're actually answering what they're asking you, not what you think they're asking. I almost got caught myself because I almost didn't put the correct answer down there, and then as I was kind of listening to them there, I go, oh crap, the way I've got that written, I'd have to have one more answer listed there. So
we're using AC instead of the heat strips, right? Because of the AC.
Say that again.
On this question, we'd use the AC instead of the heat strips because the AC is bigger.
No, this is a heat pump. And the heat pump's going to be on in both conditions, whether it's the air conditioning or the heat. The heat pump works just in reverse operation, but it's still the same piece. So it's going to fall under Section 3. And that's it'd be 100% of the heat pump, and then it'd be 65% of the heat strips if they're not designed where they operate independently. So in this case, since they're not interlocked, we would take 65% of the heat strips, and then we'd take 100% of the heat pump. So you end up with, I think, 12.425 for that air conditioning heat load. Is that right?
The AC, let's see, 230, 30,
The
6,900.
Yeah, for that one, and then 65% of that 8.5 comes out to 50.
5.5.
Yeah. And then
Yeah.
Together.
That's the only thing I left out there. 28.
And once you have that number, what do you do with it? So if we had the 12.425, where do you put it?
What number?
The heat strips and the air conditioning or the heat pump we are just talking about, that 12.425 when it's all said and done. What do you is it good? Is you finished with that? Is there anything else you need to do with that, or does it get added to something else, or where do you put that in your steps? So let me do James real quick. James, do you have an answer?
I got 71 amps. I'm 71.5.
Okay. And John, how you looking?
I'm lost somewhere.
Okay. All right.
On that heat strip, you went 65%, right?
Yeah, only because I gave you that it wasn't interlocked, so it's going to operate at the same time as the heat pump would work. So we'd have
5.5.
5.525. Yeah, is added 6,900 for the heat pump. So again, that's just 65% of that 8,500 for the heat strips. Now we wouldn't have to take it at all if it was interlocked. So if it was not going to work at the same time as the air conditioning or the heat pump compressor unit outside, then I wouldn't have to include it. All right. So before I get that's part C. Okay. Now that's the last part that we do that's independent as far as the mechanics go. The beginning of the earlier steps, the process is I'm going to take the square footage, which is 1,000 square feet in this case. So I'm looking at coming in here with 1,000 square feet times 3 gives me 3,000 total. So 1,000 square feet times 3 volt amps per square foot is 1,000. There's 3,000. Then I have to add that 4,500 because I have that no matter what on this pre-required circuits there. So I'm going to add those two numbers together, and that's going to give me a total of 7,500 there for those two. And then I moved down the list there. The range is 100%. The dryer is 100% of 4,500. The water heater is 100% of 5.5. I mean, everything else in that question is just 100%. So I'm going to end up adding 8.5, 4.5, and 5.5 to that, just straight across the board. So plus 8,500, plus 4,500. And this is the nice thing about the optional method, man. I'm telling you, it's just you just start adding stuff in there. You don't have to worry about it. And then the water heater, 5,500. So that's going to give me a total of value of, if I wrote it down right, as 26,000.
That's what I did wrong. Is that dryer? I went to 5,000. We don't do that on optional. We just take the nameplate, right?
That's right. That's absolutely right. It's just straight across the board. So that's the big difference between optional. Or one of the big differences between optional and standard is.
That was my mistake.
Yeah, anything that's in part 3 except for the derating of the neutral is out. You don't have to worry about it here, including motor load. All right, so we're looking at a total there of I got 26,000 is what I wrote down as a fast note. Let me make sure I've got that right. Plus the 8,500, plus the
16, 1, 2, 3.
Yeah, 26,000 is what I get when it's all said and done. And that 26,000, the first where we stop and go up to the top of B, which we have our derating steps. I'm going to take the first 10,000 of that at 100%, so minus 10,000 equals 16,000. And at 16,000, I'm taking a derating of 40%, which gives me a number of 6,400. So I got 6,400 with the 40%. I add the 10,000 back to that.
Okay, where's the 10,000?
The 10,000 is, if you look at the very heading of B, the instruction at the very top, tell you that we're going to take the first 10,000 to 100%. So I have to subtract it, kind of get it out of the way, apply my 40% against the balance, but I have to add it back in when it's all said and done.
The top of what? That sounds familiar. I'm not on the right page.
On page 73 under 220.82B, the very heading where it says general loads.
Okay.
So we're taking the first 10,000 at 100%. So that's why I subtracted it, and then the balance of the 16,040. So that brings it in 6,400, but I have to add the 10,000 back. So we end up with 16,400 when it's all said and done. And then to that number there, we add the other number that you came up with, which was the 12,425 for the air conditioning heating part under part C. 12,425 And those two numbers together then combined to 28,825.
Where'd you get the 12.425?
I got the 12,425 from taking 6,900 for the air conditioner and 5525 for the 65% of the heat strips under C3.
Oh, we don't derate those in the beginning?
No, that's what I was telling you, to put yourself a note at the bottom of note 4 down there on the left-hand column to make sure that you separate those two steps. The section B is done as a derate block, and then after you're done with the derating, which we did in this case, that 16,400 is our connector load for the sections B 1 through 4. And then when we're done with that, we add to that number whatever we choose out of the 1 out of 6 from the C section. So the 16,400 becomes my steps under block B 1 through 4, and then the 12,425 comes out of part C3. And it's 100% of whichever one of those numbers we pick. There's no derating factor. It's not derated by 40% or anything. So
I know we just asked this. I'm trying to catch. I'm sorry. That 12.42 is what?
It is what, if you look at section C3, that's what I calculated that heat pump out of. It came out at 100% of the air or the heat pump is going to be 6,900.
Okay.
And then I took 65% of the supplemental heat strips because it was not interlocked from the heat pump.
All right.
And when I add those two together, the 5525 for the heat strips and the 6,900 for the heat pump, it gives me 12,425 altogether. Okay. And so that 28,825 volt amps is my calculated demand load. I'm going to multiply that, don't forget, times 0.83 because it's not the same number anymore. For a residential dwelling, we're actually using a factor of 83%. So that was going to bring me down to 23.325. When I divide that number by 0.240, again, I'm using decimal points, so these are kVA values I'm using here. If you're using 23,925, it'd just be 240. So. If I lost anybody to speak up, I certainly go back and reiterate it. I don't want to.
Yeah, I got a little turned around on the. I had the 16,400. I got.
Okay.
I'm getting a little confused going back and forth from the. I'm kind of confusing myself on the using the decimals, and then you know sometimes you do 8,500 or doing 8.5.
Let me go back and change that because you're right. That's a fair comment because that's probably confusing. And I'm telling you that the method I use is I just turn them all into kVA values because it's a little easier for me to keep them all that way. But when I'm writing them down like this, I should just write them all out that way. There wouldn't be any confusion there. So these are all going to be just kVA or just VA values, not kVAs. That's going to give us 28,825, and I'm getting the 0.83% from that 310.16B7, the new multiplier that we have for residential feeders. And the way the question is asking me is they're asking me to calculate the total demand load on the feeders, what I'd actually use to size the feeder, what it's based on. And so my answer then becomes, or my calculated answer becomes a value of 99.69 amps. And just work the steps there and see if you kind of follow through there. The 23,925 was my total calculated value after I took the 83% for the feeder for the fact that it's residential dwelling. Divided that number by 240 volts, and they gave me 99.69 amps. However, the value that I'm going to base a set of feeders on for residential dwelling is going to be what?
83%.
Well, I can't have a minimum service. I can't have a service sized anything less than what size for residential dwellings?
100 amps.
100 amps. So my technical answer would be 100 amps, which is that fourth one down at the bottom, technically, because after all the math is done, if I'm less than 100 amps, I'm still going to end up having to have a service size at least at 100 amps. Does that make sense?
Yes, it does.
Sort of. Sorry, I'm not trying to confuse you. It's likely to be a question that you might see. So it's one of those things that, if they ask you for a breaker size, I'm going to size the breaker at 100 amps. I mean, it's you're going to round that up to the next standard size overcurrent protection device anyway. So Might be an easier way to look at it that way, but and I think that's what they asked you on this question specifically. So. Yeah, here we go. That's one right there. All right, so if you had dryers just by themselves, let's stop this. And the answer here then is going to be minimum size 100 amps there in case there's 100 amps. And again, I'll send you a copy of these things if you want to have a record of it along with the video, so you can go back and speed through it and kind of pick out the parts you want to kind of review again. Individual loads, when I'm talking about back to the standard method, okay? So we're done with optional method and we're moving back to the standard method to kind of pick up a couple of things. I'm looking at individual loads for dryers, right? Dryers are going to be one of those things that you kind of have to be careful of. First and foremost, we're looking at page 69 and 70, I think. No, 70 and 71, excuse me. Bottom is 220.50 for the dryers. And the table that's on the left-hand side of page 71. The table, by the way, guys, that's on the right-hand side, make sure that you mark that on the top of it. Just put commercial cooking equipment. The one that's on the left-hand side, put residential dryers only. So the table .54 that's on the right-hand side of page 71, you cannot apply that to commercial dryers. Well, let me rephrase that. A commercial dryer used in a residential dwelling, you could, but a commercial dryer in a commercial setting, or a residential dryer for that matter in a commercial setting, that table could not apply to that. There is no table for commercial dryers, really. And there have been a couple of questions, guys, out there about some dryers in like a laundromat area where they're not a laundromat on a residential like apartment complex, because that would apply in this case under this table. But if it's a like a quick wash or a coin operated deal down on Main Street, that's going to be 100% of those values. There's not any table derate dryers that are not residential in nature. Okay. So you're looking at a pretty simplified table, the minimum value being 5,000 no matter what. And so on that table that's on the left-hand side of page 71, put 5,000 watt minimum real big across the top of it so you don't forget. And it comes out of the article that's just on the bottom of the preceding page like we looked at earlier. So if you had a question like this where you're looking at 6 dryers all together and they're all residential dwelling, I had 6 electric dryers, a pair of them that are 4.5 kW, a pair of them that are 6.0, and a pair that are 5.5 kW. The only thing to bear in mind, to be careful of, is that you're looking at taking an uptick on those first pair. I got to have at least 5,000 for both of these here. So instead of this being 9 kW, this is going to be 10 kW, okay? And if they don't tell you anything, in this case, since there's not a word up here about standard method or optional method or anything else, this will be standard method because that's your default. So it's 10K plus 12K plus 11K is going to be your beginning step. So I've got 6 dryers here at a total of 33 kVA. So my table for the dryers for 6 of them is going to be a derating of 75%. So multiply that times 0.75 and that'd be your answer. Okay. So I'd take 33 times 75. What's it give you?
24.75.
24.75. 24.75. kVA. Now, what would again? This is if I'm talking about the feeders, right? The phase conductor. I'm sizing residential dwelling. I've got these 6 dryers, and I've got a bunch of other stuff, the square footage and the air conditioning, the ranges, whatever it might be. I would add all that together, and this 2475 or 24,750 is just an amount that's added to the total, overall demand load to size the feeders. But if we're looking at the neutral for residential dwelling, to size a neutral for residential dwelling, there's an allowance under 220.61 on page 71. And if you look at it real quick, it gives you an allowance to take a value of 70% against a range or a dryer in residential dwelling against the calculated values under the tables as well. So we're looking at, in this case, under B1 on page 71, it's at the very bottom right-hand corner of page 71 under B1, 220.61B1. Service feeder supply and following loads permitted to have an additional demand factor of 70% applied to the amount. Under section 1 there, feeder, applying household electric ranges, oven, cooking units, electric dryers, where that maximum balance load has been determined in accordance to the tables, which means I'm going to take that 24,750, and if they were asking me for the demand against the neutral load, I would multiply that times an additional 70%. That makes sense?
Yes.
Just FYI, I'm not saying that there have been some cases in the past where they've given you questions or asking you to size the neutral conductor for residential dwellings, and just remember there's a 70% allowance for the 240 volt circuits that are for the water heat, the range and the dryer. Okay. So if I were to have, let's say I had 41 dryers, and I'm asking to size the neutral for 41 dryers. And this is one that was pretty common for a while, and then it kind of disappeared, and then it came back, and I can't tell you honestly if it's still there or not. But you took your test not too long ago, Robert. Do you remember any big dryer questions like 21 or 18 dryers or 41 dryers, something like that? Anybody? James, do you remember any dryer? Have you taken your test, James?
Yeah, like 2 weeks ago.
Okay. Do you have any dryer questions?
Yeah, there was a dryer question. It was like 18 or something.
18. Okay. That sounds familiar. We'll do 18 of them. Were they asking you for the neutral or just for the demand against the feeders?
Yeah, it was just a feeder question, I believe.
All right. So let's look at the table then real quick, and I'm going to go through and do an example. Man, I tell you what, James has got something going on over there. I tell you, he's got a couple of chicks sitting right in front of him. I wish you'd sit the other direction so we could see what you're seeing.
Always by a pool.
He's laughing. He knows what I'm talking about, because every time I turn him on, that's all I hear is some chicks in the background laughing. All right, so we're looking at the table there. It stops after 11 dryers, and it's got this strange math here. It says 12 to 23 dryers is 47% minus 1% for each dryer exceeding 11. All they did, guys, is that 11 dryers on the table there, they got lazy, because 11 dryers equals 47%, right? If you're looking on the table. You're just basically, anything less than that, I'm turning around and I'm just basically adding subtracting a value of hold on 1 second, let me do a layout here. Just need that table content so I can type on in here. Delete that. All right, so if I had 11 dryers on this table, my calculated value would just be simply 47%. Well, what they did was they just got lazy and decided instead of writing that 12 would be 46% and 13 would be 45%, so on and so forth. They gave you this strange math where you had to do your adjustment on the fly. But all it is I'm just subtracting or lowering that demand factor that I left on the 11th row there by 1% as I go down the list there. So it's 45% at 13, so on and so forth. So I'm just going to take the net number. So if they gave me 18 dryers, for example, right? 18 dryers, I'm going to have to subtract from that number the initial 11, which is where the table kind of stops and starts that funny math. So that's a balance there of what, 7 additional dryers. 11 minus 18 is, in fact, 7. Each one of those dryers is going to subtract 1% from that level that we started at up here at this 47. So if I were to just continue my list down here, I'm just subtracting 1%. So it's really 7 dryers, each one of them being 1%. That's really 7% is what we're looking at. That's going to be subtracted from the 47%, which is what 11 dryers would be. And so I end up with adjusting my value there to a value of 40% then of the nameplates. Or 5,000 watts if they happen to be 4,500, or if they don't give you a value at all, if they just said 18 dryers, what would the calculated value be? Then it's just going to be 5,000 watts, because that's my minimum I have to have under the article. And then my derating would happen just like that. So I would end up ultimately taking 5,000 watts and multiply that times the value of 18 units, which give me my total connected load of all of them at 100%. So 5,000 times 18 units would give me 90,000 VA or 9,000 watts. And I would then multiply that against my new calculated derating value of 40%. Did I go too fast, or is that pretty easy to swallow? So it's 36,000 total kVA. I usually use the calculated demand, or excuse me, the calculated demand load as a volt amp value, or they express it in volt amps, and the watt value being a connected or nameplate load for appliances. But they're interchangeable. I could call that 36 kW, or I could call it 36 kVA. It would not make any difference at all, according to actual wording there in the article 220.54 or .55. Both tell you that the kVA and the kWs are going to be the equivalent rating according to those sections. So there's no difference. Okay. Any questions on that? James, I'm going to turn you back on again. Tell those girls to be quiet for a second.
Okay.
No, I'm just kidding, man. I'm just kidding. Don't worry. We can hear you. It's not that big of a deal.
Okay.
I was just trying to give you an excuse to talk to them. What good's a wingman for, right?
Right.
All right. So is that, or do you remember if they were asking you for the demand on the total deal, or the nameplate ratings on any of them, or what did they give you? Or do you even remember?
I don't remember on that dryer question.
Yeah.
Yeah. I can't remember what it was.
Somebody told me, guys, that there was a question out there that were for commercial dryers, and they didn't give a nameplate rating on them. But I want to caution you again that Section 220.54 is a residential dryer calculation. It is not for commercial use. In fact, there is no table at all whatsoever for commercial dryers. So if I'm doing a laundry mat, I'm going to take the nameplate rating of whatever they give me, and I'm taking These girls are just getting crazy. Almost sounds like you're at a frat house or something. But anyway, so we're looking at if this was a commercial question, I'm taking this 90,000 VA. I'm not doing any derating, but I'm not going to increase it for continuous duty either, because the nature of what a dryer motor is that at some point, 60, 70 minutes or whatever it's going to be, it's going to stop for somebody to pull out that load, put in another load. So that being the fact that the 3 hours is our mark that we start considering continuous duty factors, dryers would not be, by their own nature, would not be considered continuous duty. So if it's a commercial question and they gave me nameplates, I'd just take the full value at 100% and be done with it. Okay.
Okay, so what I did at first, and when you say 18, you're not taking 11 of them, subtracting it from that 18 and doing 47%, and then doing the remainder.
You're not doing two different rating steps.
That just means anything over 11, you're just straight up using whatever your subtraction is in that 1%.
It's the whole block of all of them,
Okay.
Yeah. That's a good question, because that's been asked many times, but it's not a two-step process. It just you just got to adjust your demand factor, but once you adjust it, it applies to the whole group.
Seems simple.
Okay. Now let's just to be covered, just as another example, just be done with it. I'm going to do the one that was 41 dryers. At 41 dryers, the only thing that changes that is instead of being a 1% derate for each additional one, they've already lowered that number through the process of 1 through 23. So when I get to 24 to 42, I'm just taking 0.5% for anything above 23. So if I had 41 dryers, I would take 41. I would subtract 23 from that number. And again, I'm on that second line there on the table 220.54. That would give me a balance of 18 additional dryers. So 41 minus 23 is 18 additional dryers. Each one of those dryers, like the previous example, but in this case only being 0.5%, I would take 18 dryers at 0.5% for each one of those. It would end up ultimately giving me 9% as a derate or a reduction on that derate factor. So I'd take 9% then, and I would subtract it, but now I'm subtracting that 9% from 35%, which is where that block starts at. So it's 9% subtracted from 35. Because it's only 0.5% for each one of those dryers. So it's 18 dryers at 0.5% each one of them, which equals 9%. And that 9% is then subtracted from 35 instead of the 47 the other line was. So we've adjusted that down to a value of 20. Let's see here, minus 35 is 26%. And again, just like we talked about before, I would take that 26% against all of the 41 dryers. So I'd go back to the top 41 dryers at 5,000 watts. If they didn't give me a nameplate, I'd have to use that number. And then I'd end up giving me 205,000 total watts. And I would multiply that entire number times a factor of 0.26. Gives me adjustment of 53. Let's see here, 205 times 0.26, 53,300. Okay. That's an exact number. So if you have a question that's similar to that, and it's going to be that one almost verbatim. So it's not a bad number to jot down in the corner of the page or something, just in case you have it. 41 dryers would be 53.30 kVA, and that way if you have it, you don't even have to worry about working on it. Okay. 4 fast in place or 4 more fast in place appliances under .53, we take a derating against those. I'm seeing that come up, but I'm not seeing that being a big calculation or anything. I'm just seeing them asking you what the number of appliances you have to have in order to take that derating to 75% or something of that nature. So if you take that 220.53, you have to have 4 more appliances that are fastened in place. That does not include the range, the dryer, the electric heating. So additional units or whatever that would be fastened in place at 75%. And I think I'm going to call that good for that. Let's see. Is everybody comfortable with the ranges under the standard method?
The what method? Oh, standard, yeah.
Ranges. Okay. And Robert, I know you're sick of dealing with ranges because I think you've set to a couple of ranges since then. So are you pretty good with them, Robert? No. Robert, you're gonna look like me if you keep doing that hair rubbing stuff. I'm telling you. You know what I'm talking about. You don't want to say anything, but you know exactly what I'm talking about. Too much stress will make you go bald like John and I.
It's not a fashion statement.
Yeah, it's not something that's true. I don't think I'd get a haircut for a year if I could grow it. Just to be out of excitement. Anyway, all right. So I'm going to leave that there. Is anybody? I'm going to have to. I got about 15 more minutes. I'm going to leave this to you guys. What is there anything else you guys want to ask me or cover before we wrap this up? James, I'm gonna take yours off too, so we can hear you.
Yeah. Did you get that question I asked about the emergency systems? There was a question. I don't know if you can hear me.
Yeah.
There was a question on the test asking about what systems are allowed to be on the emergency system. The answers were optional standby system, critical emergency system, and something else, but I couldn't find it in the code book. What systems are allowed to be on the emergency system?
It's probably a question that's really talking about the systems in a hospital. So you're going to find that one probably in 517. Let me get my book here. 517. I heard that question before, but that's and of those, emergency system. Let's see here. Page 4. Well, actually, essential system. 3 there.
Dan ne bijaj, uno je da ću ja, čim nađem neku, jer moj
Which is the equipment branch.
da ću ja, dođe neka prilika, neki ono to, ali mene niko nije zanimao život.
Page 469, kind of that informational note figure, number 1 and 2. Did they give you essential as one of the options?
Yes.
That'd be what I would answer. Does that look like that takes care of that one?
Yeah. Okay. What page was that?
Page 469 is kind of a little, it should see a little diagram like that.
I got it. Yeah. That's it.
That's an interesting way to ask that kind of question because it almost wants to, did you spend a lot of time in 700 looking back there?
Yeah, actually, well, I was in this section, but I was looking in the paragraphs for the wording. But when it explains it like that, it makes sense. Yeah. Okay.
Yeah. All three of those are part of the essential electrical system, which would be if that's one of the answers that you found, that's the one I'd grab at. Systems are permitted to be on the emergency. Did they tell you that they use the word healthcare or hospital or anything in that question?
It was healthcare, I believe. Healthcare, yeah.
Okay. All right. Any other questions? Anybody have any special requests or anything else they want to cover?
No, I said Monday would be another chance to go.
Baš sam ga taj put, meni se strah. Nemoj da, jer milion puta je to dobro. Ne, sad, znači, jer ono kad se opet sad.
Yeah, I'm saying. All right. So if you guys want, I'll pull a couple of examples out and I'll send them to you by email and you can work them out over the weekend or for that matter. Man, I'm not trying to tell you that I can't answer questions. It's just I'm not going to be officially back on. Let's see, tomorrow I've got I don't have anything scheduled specifically for tomorrow night, but as far as just some answers and stuff, I could send you some this evening probably. And just give you the weekend to kind of review them, and then if you wanted to kind of log in earlier than 5:30 on Monday, then we could kind of review those kind of questions. But only if y'all think it would be helpful to you. My opinion, honestly, of the service calculations, to be honest, is that it's too much work for the kind of points or the kind of volume that you have to do. So I mean, you're looking at a question that every one of those examples was damn near an hour to explain and trying to do the steps of it. Even if you're good at it and know what you're doing and don't have any issues with it, it's still going back and double checking yourself 4 or 5 times. It takes 15 minutes. You just don't have that kind of luxury for a question that's worth 1 point on a test. I mean, it'd be the last thing I did if I had an hour left, just to waste and didn't have anything to do. I might do them then, but it'd be the last questions I do.
Do you see them a lot?
They're on. You'll have 1 or 2 of them on every test. So I mean, they're for sure there. It's just that even if there's 3 of them, it's still it's 3% of your score. It's a lot to keep track of, and it's a lot of steps to keep straight. If you don't keep those steps straight, they're going to give you answers that are going to be calculated by the missteps that are common for guys. So if you're missing something everybody else misses, you're going to feel pretty good about getting one of the answers probably, or maybe if you get lucky, maybe you will. But at any rate, it's I still think it's not that hard to learn how to do them, but it's one of those things that I just don't want to kill you with a bunch of examples and have you work all weekend on them and only have impact on 3% of your exam. Does that make sense? Mm-hmm. All right, so motors, there's 8 of those as a block, plus you have some motor stuff that happens in the feeders line, which is the 3rd line. So I think that's probably worth more of your time. So I tell you what I can do. I'd rather do maybe 4 or 5 just service calculations, just so you'll have a couple of them to practice on, but then give you a block of motor questions, and then we'll review those on Monday. That way you'll have something to kind of use as a precursor to the class. That way you'll get a little run up to it. How's that sound?
Sounds good.
Okay, and I have something already worked out for that, so it's not something that I have to work on or you have to wait on. So I'll send that to you right when we're done. Did everybody get the ID number for the Monday meeting?
Yeah.
Okay.
You still want us to email you at that Strail?
If you want a copy of these slides, I'll be more than happy to send them to you.
Okay.
Hey, Robert. Robert's waving at you. I love you too, Robert. I don't know what he's trying to say. He's either trying to bat a fly away from his computer, or he's saying that I'm the most handsome guy he's ever seen in his life, and he just doesn't know how he'll ever survive. And the rest, knowing that he's so okay. Sorry, going off the. All right, send me a chat message, Robert. I can't hear you, bro. All right, John, if you have any other questions. Specific?
No, I look forward to those practice motor deals, and then we'll chat about those on Monday.
All right, man. Are you scheduled for your test yet?
No, Iowa is the one I want to take first, and I had to send in some sort of unclassified something or other, pay $13, and then they got to sponsor me.
Okay.
Iowa's a little funny when it comes to that, so I'm waiting to hear back from my sponsor.
Okay. All right. Well, then my fear was that since we were kind of so late in the game after the class that you were kind of running up again on a time deal. But if you've got a couple more weeks, then I think we're pretty comfortable.
Oh, I definitely do, and I need them. I really do.
Okay. All right. Well, we'll do motors then on Monday, and then we'll just keep doing them like that and just knock them out one block at a time.
Sounds good to me.
All right. Well, have a great evening, and John, appreciate you logging in with us.
Thank you for your time, Mitchell.
Hang on, Robert.
I'll catch you later.
Okay, man. Have a good evening. All right. So, Robert, I'm going to just open the chat because I don't know why I can't hear you. Oh, there was some chats on here. Oh, yeah. I should have looked at that. All right. So, can you see the chat window? Maybe see if it'll automatically pop up. Can you see that? It's backwards. No wonder you couldn't see my. Okay, there you go. All right. Oh, you're talking about the ones in the back. I got you. Okay, so you're talking about the ones in the back. Okay. Yes, let me send you a copy of an answer key. Okay, answer key tomorrow. The ones in the front at the ends of each section I'll send separately because I've got answer solutions for those. Okay. We'll see you Monday, if you're available Monday. Okay. All right. Hopefully so. If not, just keep. Are you? I don't know if you're scheduled for your test or not. I want to say that she told me you were scheduled. Oh, take Saturday. Okay. All right. I'm going to send you. Can you hear me? Okay. I've got a list of questions that came off of a couple of guys' master's exam that was from the 2011 exam. And I stopped passing them out to classes because I felt like they, once they changed it, probably they got rid of most of those questions. Well, I gave it to a couple of guys that had been doing some one-on-one tutoring with me here at the office, and they had taken that. The next day, they both took their test on the Saturday, and they called me both on Sunday and said that a lot of the bulk of that stuff that I'd just given them was on their test just that they'd just taken. So I'm going to send you that copy, but don't forget that in the middle of your textbook there is a list of stuff that should be kind of in the very middle. It's kind of a kind of running tally of some sections that were on somebody's master's exams. And that's somebody that just took his master test the other day and passed said that was what made the difference for him was that one section in there. So until you get the other ones from me, make sure that you go over those, like on page 45 or 46, somewhere in the middle of the book there. And it's just a list of things that were on. Okay. Good. All right. I'll send that other stuff to you tomorrow. That way you'll have some time to review it. And I would spend my last few minutes on Friday night kind of doing that review over the stuff I email you. Okay. And if you could send me an email just so I've got it ahead of me, I'd appreciate it. All right. Have a good evening, sir.